Short-range navigation radio system simulator. This work is devoted to the description of the key aspects of the development and use of a computer simulator of a short-range radio engineering system. The simulator should allow to simulate a wide range of situations of interaction between the beacon and the aircraft and provide simple interface to allow users easily construct required testing scenarios. So the main purpose of the work is researching of the main aspects of RSBN systems and demonstrate them working via the user interface. Our tasks are following: analysis of the current state of the issue in the subject area is given. Requirements for a modern RSBN simulator. Description of proposed simulator experiments with it and interpretation of the results of experiments. Summary and recommendations. Currently, the ICT market segment dedicated to the development and use of simulators for a wide range and purposes is actively developing. The best known are driving simulators and biomedical simulators. They can be simple video games or professional VR intelligent systems, such as for plane for pilots training purposes. The professional simulators allow to dive into the process under consideration as realistically as possible to get a holistic view of it, to learn how to effectively manage an object or process. The development of modern computer simulators of short-range radio navigation systems is relevant, mainly for the purpose of operational training in working with RSBN. An analysis of the current state of the issue shows significant progress in the field of building a variety of simulators and relevance of using models. There was research the basics of radio navigation, the model and technologies for modeling scenarios as well as generating targets with their ranges and speeds for radars were researched. The work presents short-range intelligent navigation technologies based on IoT. The main purpose of the short-range navigation system is to bring aircraft to the landing airfield and provide navigation when flying along the road over the continental part of the Earth's surface. The purpose of the developed simulator is to simulate signals of the radio beacons and the aircraft, emulate all the equipment of the system, and visualize the navigation on the map. The use cases planned are construction of aircraft flight scenarios, modeling of signals passing in the ranging and azimuth channels, simulation of receiving transmitting equipment, visualization of navigation instruments, and displaying the radio beacon and the position of the aircraft relative to the beacon, azimuth and distance. Verification of real signals and equipment of the short-range radio navigation system. The researched short-range navigation system has two range-finding and azimuth channels. The ranging channel of the RSBN system consists of an interrogator installed on board of the aircraft and a beacon transmitting responses. The aircraft transmitter emits pairs of pulses, interrogation pulses, which are received by ground-based stations, and after the process inside it emits response with range received by aircraft interrogator. The azimuth channel provides information about the azimuth position of the aircraft. According to the research and formed requirements, the RSBN simulator was developed. It's built with using web technologies as two applications, backend and frontend as client-server architecture. Backend is built as microservices that operates airplane scenarios, beacon placement and signals calculations, and event-based bus between them such a Redis sub. The frontend is a single-page application with map and functionality to place beacons, change their parameters, constructing and playing scenarios. Before the carrying out of experiments, there should be created a beacon placement and constructed a route of aircraft flying. Interface shows the beacon params and the corner points with plane params there. There is support for many point scenarios, 2 points and 1 point scenarios. When the scenario is launched, the interface constantly shows changeable plane params, such as speed, altitude, bearing, and coordinates. The plane radar shows beacons with their coordinates and heading to them. Also, we can change the station to interact. There was also carried out experiments with many point scenarios and 2 point scenarios. The obtained results of positioning the aircraft and selected beacon were gathered in tables. For the results assessment, a group of experts were involved. They, they measured the parameters and compared estimates of simulator parameters with observed ones. The evaluation showed not only the adequacy of the estimates of the azimuth and slant range parameters, but also the high efficiency of the simulator in the whole. For summary and recommendations, there are the main purposes of the software simulator is to carry out a computer simulation of the interaction between the aircraft onboard system and RSBN beacons to reduce costs, eliminate the need for full-scale experiments with real equipment. Simulator is easy to use and effective in its computations near to the real equipment. Recommended to be used in learning systems to allow pilots and service personnel to learn and gain practice. To conclusions, we solved tasks. An analysis of the current state of the issue in the subject area is given, requirements for a modern RSBN simulator, a description of proposed simulator, experiments with it, the interpretation of the results of experiments, and summary and recommendations. Thank you for your attention.